All right. So we're doing problem number 17.40. 17.40. Deuterium oxide D2O ionizes like water at 20 degrees Celsius. Its Kw, or its ionization constant, autoionization constant, for ion product constant, analogous to that of water, is 8.9 times 10 to the minus 16. So we have 8.9 times 10 to the minus 16. All right? And so we want to calculate the concentration of D plus and the concentration of OD minus. So deuterium oxide, D2O, is basically H2O, right? So here's oxygen with a hydrogen and a hydrogen, right? This hydrogen contains one proton and one electron. This hydrogen contains one proton and one electron. D2O is oxygen with, instead of one proton, a proton and then a second neutron, all right? Still has just one electron. So here's the oxygen. This is hydrogen. We call it deuterium though, so because it's just hydrogen, but it has an extra neutron. So the mass is different, okay? And there's the electron. So this is D2O. The difference is these hydrogens actually contain neutrons, all right? So that's D2O. Its Kw, or ion product constant, is that. And so we want to calculate these concentrations. So this 8.9 times 10 to the minus 16 equals the concentration of D plus and OD minus. Alright, so we can take the concentration, or the value 8.9 times 10 to the minus 16. Divided by 2, and that should be our concentration of those two components. Alright, so we have 4.45 times 10 to the minus 16. Let's double check that one. 1740. 1740, right? 1740, am I looking at something else? 1740. Oh, I was looking at the practice exercises. So the practice problems. 1740, 3 times 10 to the minus 8th. Oh no, not divided by 2, but the square root, right? Let's see, 8.9 times 10 to the minus 16. Yeah, square root of that value. 2.9 times 10 to the minus 8. Alright, or 3 times 10 to the 8th. Okay, so we got that, because the concentration of this times the concentration of that has to be equal to that. So these concentrations have to be the same again, because for every D that comes off, you leave one OD minus. Alright, and then we have to find the PD and the POD. So, to find the PD, PD, this is the concentration of the D, so we just take the negative log of that. So we take negative log of 2.98 times 10 to the minus 8th, and I'm looking at PD of 7.5. And because that's the same, that value is also the concentration of the POD, I just have to take the negative log of that. So the POD will also be the same value, 7.52. So we'll check that. 740 there, 7.52. Okay. Great. Gotta get an eraser here. (742). Calculate the H plus concentration, the pH, and the pOH in each of the following solutions in which the hydroxide ion concentrations are given. All right, so if we have the hydroxide ion concentrations given to us, 742, the concentration is 0.0068, 0.0068 molar OH minus. All right, if that's the hydroxide ion concentration, then right from that we can identify the POH, right? All right, so we have, that's the concentration of hydroxide ion. Hydroxide ion concentration 0.0068. So we can take the negative log of 0.0068, and that'll give us the POH. So the POH is 2.16. This is all for A, right? 14 minus that value will give us the pH. 742, we want the pH, the POH, and we want the H plus ion concentration. So we need to put 10 to the negative 11.83, and that'll give us the hydrogen ion concentration. So 10 to the negative 11.83. So the hydrogen ion concentration is 1.48 times 10 to the minus 12. For B, 6.4 times 10 to the minus 5. B, the hydroxide ion concentration is 6.4 times 10 to the minus 5. Negative log of that value, 6.4 times 10 to the minus 5, 4.19. So that's the POH, 4.19. 14 minus that value, pH is 9.81. 10 to the negative 9.801. Hydrogen ion concentration is 1.56 times 10 to the minus 10. All right, we'll check the answers on those two. 742. 1.5 times 10 to the minus 12 from A, 11.8, and 2.17, 2.16. Okay, good. Second one there, 6.45, 1.56 or 1.6, pH 9.81, 4.19. Okay, so for 1442, I'm going to stop there. You can do C and D by yourself probably just fine. Alright, 1444. A certain brand of beer had a hydrogen ion concentration equal to 1.9 times 10 to the minus 5. And that's the molar concentration, correct? Molar, what's its pH? This is the hydrogen ion concentration, right? So to take the pH, we just go the negative log of 1.9 times 10 to the minus 5. So we're getting a pH of 4.7 for the beer. 1744, 4.72. All right, 1446. Calculate the molar concentration of hydrogen ion and hydroxide ions in solution that have the following pH values. All right, pH is 8.14. That's the pH. We need to calculate the, let's see, I'll set it up like this. The pH, and we need to identify what else? Okay, the molar concentrations of H plus and the molar concentrations of OH minus. So we need to find the H plus concentration and the OH minus concentration. For A, the pH is 8.14. So 10 to the negative 8.14 should give us the hydrogen ion concentration, 7.24 times 10 to the minus 9. There's our hydrogen ion concentration. Right? And that means the hydroxide ion concentration in an aqueous solution would be 10 to the minus 14th. So we have 1 times 10 to the minus 14 divided by this value here, and the hydroxide ion concentration is 1.38 times 10 to the minus 6. Let's see if I did that right. 1746A. 1.4 times 10 to the minus 6. All right, good. So we'll do that one more time. B, 2.56. So we take 10 to the minus 2.56. All right? And that will be our hydrogen ion concentration, which is 0.002754. And then, again, the hydrogen ion concentration times the hydroxide ion concentration has to equal 1 times 10 to the 14th. All right? So, 1 times 10 to the negative 14. So, that is how we identify this concentration here, right? So we take 1 times 10 to the minus 14 divided by our identified concentration of hydrogen ion here, and that should give us the hydroxide ion concentration. So 1 times 10 to the minus 14 divided by this value here gives us 3.6 times 10 to the minus 12. 1746. All right, great. So we're going to leave a couple for you guys to do there. (1748). The interaction of water droplets in rain with carbon dioxide that is naturally present in the atmosphere causes the rainwater to be slightly acidic because carbon dioxide is an acidic anhydride. Now you remember what an acidic anhydride is. It's a chemical that when it's mixed with water, it will make the solution acidic. Okay? So, it's saying that water, as it falls from the sky, mixes with carbon dioxide to form carbonic acid in the water, making the water acidic. As a result, pure clean rainwater has a pH of about 5.7. So the question is, what are the hydrogen ion and hydroxide ion concentrations in the rainwater? So if the pH is 5.7, we want to know the H plus concentration and the hydroxide ion concentration. Okay? To find the hydroxide ion concentration, we can go 10 to the minus 5.7. That's the hydroxide ion concentration. 2.0 times 10 to the minus 6, really. 1.995 times 10 to the minus 6. 2.0 times 10 to the minus 6. And again, to get this, the sum of these two always has to equal 1 times 10 to the minus 14. We take 1 times 10 to the minus 14 divided by the hydrogen ion concentration, and we get 5.0 times 10 to the minus 9. 1748. All right, that's good. So that's using strong and acids and bases. 1750. What is the concentration of hydrogen ion in 0.00065 molar nitric acid? 0.00065 molar HNO3. All right. So we have HNO3. Well, it's a strong acid, right? So if we put a strong acid into water, then it completely ionizes, completely dissociates, right? And completely, the concentration of hydroxide ion is going to be equal to the concentration of the acid. So, concentration of H plus ion in a liquid that contains, a solution that contains that much nitric acid is going to be 0.00065 molar. Now to find the pH of that, we just take the negative log of the concentration, negative log of 0.00065, and that should be a pH, which I'm getting 3.18. So pH of that solution will be 3.18. And what else did they ask? What is the OH concentration in the solution? Well, we showed you how to do that using the H plus concentration. I'm going to show you another way, which is basically the same way, but just slightly around a different angle. We can identify the POH, right? We can identify the POH. The POH has the relationship that the POH plus the pH is always equal to 14. So if we take the value 14 and we subtract our 3.187, then we get a POH of 10.81. All right, and that POH, now we can take the log, or sorry, 10 raised to the negative 10.81, and that'll give us the concentration of the hydroxide ion in solution, which is 1.5 times 10 to the minus 11. All right, 1750. 1.5 times 10 to the minus 11, 3.19, and the hydrogen ion concentration. All right, got that. All right, so we see that there's a couple ways, basically the same way, but they're mathematically different pathways to get the same answer. 1752. Sodium hydroxide solution is prepared by dissolving 6 grams of sodium hydroxide in water. What's the molar concentration of hydroxide ion in solution? What are the POH and the pH of the solution? What's the hydrogen ion concentration? So we want to know the hydroxide ion concentration, pH, POH, and ultimately also the hydrogen ion concentration. All right. Well, we put in 6 grams of sodium hydroxide. Sodium hydroxide has a molar mass of sodium's 23 plus oxygen 16 plus hydrogen 1, so we have about 40 grams for every mole. All right, and we put in 6 grams. 1 mole of sodium hydroxide has 40 grams, and we put in 6 grams. Therefore, 6 divided by 40 tells us that there's 0.15 moles of sodium hydroxide. So if there's 0.15 moles of sodium hydroxide, and that's in 1 liter, so 1 liter, so that's 0.015 moles for every liter, that's 0.015 molar. Therefore, the concentration of hydroxide ion, because there's 1 released for every sodium hydroxide, and sodium hydroxide is a strong electrolyte, strong base, completely dissociates. The concentration here of hydroxide ion is 0.15 molar. POH, we can get quickly by taking the negative log of 0.15. What did I do wrong there? Negative log of 0.15. POH. This is the hydroxide ion concentration. So, make sure I'm getting this right. What's going on here? Come on. The sodium hydroxide solution is prepared by dissolving 6 grams. 6 grams, 40 grams for every 1 mole, 0.015 moles, so 6 divided by 40. 0.015 moles, and that's per liter. What's the molar concentration of OH minus ion? OH minus has to be 0.15. Hydroxide ion concentration. Oh, that's right, that's right. We're trying to get the POH. The POH here is 0.8239. That means the pH is 14 minus 0.0839, which is 13.18. So here's the pH, here's the POH, and now we can find the pH, or the hydrogen ion concentration, by taking 10 and raising it to the negative value of 13.18. Alright, so that's 6.6 times 10 to the minus 14. 1752. POH is 0.82, 13.18 is the pH. Hydrogen ion